49, because that's 7 times 7. And then we go 8 squared equals 64, 9 squared equals 81, 100 squared equals 100, 11 squared, somebody know that one? 121, 12 squared is 44, 13 squared is, okay, and the rest you can do on calculators, right? Does that make sense? Is it 189? What? You could. Yeah, you could. You absolutely could. So, anyways, this is important. We call these numbers perfect squares. So this is squaring is a mathematical operation, and in mathematics we always want to have an inverse operation. We want to undo what's being done. So I have all these terms, but now let me ask you this. What do you think the square root of 4 is? In other words, what number do I square? So think of it like this. This is 2 squared. And we don't write it down, but we're taking the square root. We don't put that little 2 there. We could. But what happens is this little 2 cancels with this one, and we're left with 2. When I say what's the square root of 9, I'm really saying what's the square root of 3 squared. The square root undoes the square, and I'm left with the base, which is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. Square root of 100 is 10. So this is called square root, because when we take the root of a square, we're undoing the squaring. These are 2 separate terms. This one has the word root in it. This one just has the word square. Sometimes people get them confused because they both have the word square. Okay? All right. So as we move forward, when we think about this, we're going to start taking the square roots, but there's properties of radicals, okay? So one of the properties of a radical is that when I say the square root of 9, really what I'm saying is this is 9 to the first power, and I'm taking the second root, which could be rewritten as 9 raised to the 1/2. This is a little tricky. Okay. So what I need to do is I'm going to turn the page in a second. Can I turn the page yet? But we're going to have to review the properties of exponents, because that's kind of a big deal for what we're going to do today. How about now? Can I go now? Okay. So now, let's kind of review the properties of exponents. What if I say 2 times 2 to the 3rd power times 2 to the 4th power? Does anybody know what that is? Well, I noticed that the base is 2. In other words, the number that I'm multiplying by itself is what we call the base. This is what we call the power, and that's how many times we multiply it. Okay? So, what does 2 to the third power mean, though? Doesn't it mean that I'm going to say 2 times 2 times 2 3 times? Is that what it means? Well, what am I doing here then? Same thing, but how many times? 4 times. So I'm saying 2 times 2 times 2 times 2 times 2 times 2 times 2, right? So here I've got 3 times, here I've got 4 times. How many times am I multiplying 2 by itself total? 1, 2, 3, 4, 5, 6, 7. So whatever the answer is, isn't it the same as 2 to the 7? Yeah? So what if I wanted to create a rule? What if I wanted to say a to the m times a to the n is equal to, what's the rule that I'm going to make up? What did I do up here to get this number? Can I say m plus n? In other words, isn't 2 to the 7th the same as 2 raised to the 3 plus 4? Is that the same? Now, we're going to do 2 rules today. One is when you raise a power to a power, and the other one is when you multiply an exponent times another exponent. So this is the first rule. Okay? We'll come back to that in a second. Let's do another example. I'm going to say 2 cubed raised to the 4th power. What does that equal? Well, if I can't remember the rules, I've just got to break it down. I've just got to write down what it means, and then I can come up with the rule. I'm saying that whatever is inside the parentheses, I multiply it by itself how many times?
3.
No, listen to the question. What does this 4 mean? It means whatever is in the parentheses, 1, 2, 3, 4. I'm going to multiply this, whatever this is, by itself 4 times. Does that make sense? So that means I'm going to put 2 to the 3rd here, 2 to the 3rd here, 2 to the 3rd here, 2 to the 3rd here. Whew, this is a lot of thinking first thing 9 o'clock in the morning. So now what does 2 to the 3rd mean? Mm-hmm. 2 times 2 times 2. That's just this one. Then I got to do it again. 2 times 2 times 2. That's this one. 2 times 2 times 2. That's this one. And then again, I got to go 2 times 2 times 2. Did I make any mistakes? Does everything I've done, does that seem like legal moves? Does that seem legit? Okay, so how many times am I multiplying 2 by itself? 12 times. So could I say this is the same as 2 to the 12th? Yeah. So if I were to create a shortcut, what am I doing with the 3 and the 4 mathematically? What do I do mathematically with the number 3 and 4 that gives me 12?
Well,
multiply. So the rule is 3 times 4. When you raise a power to a power, you multiply the powers. In other words, this would be 3 times 4. But when you're multiplying a base times a base, you add the powers. Okay? So the general rule would be a to the m raised to the n, raised a power to a power. Then the rule is a to the m times n. Okay? Any questions before we move on? I haven't even done the example yet.